Hey guys, welcome back to my channel. Um, Yesterday and day before we were talking about stacks and queues. Today we're gonna go a bit further into stacks and queues. Especially I'm gonna talk about monotonous stack. So when a stack is monotonous, it means that it is never decreasing or increasing, and its elements are always sorted. So it could be monotonously decreasing, which means that it will be sorted decreasing or increasing, monotonously increasing, and it's increasing. When it's useful when um, you want to find the next greater element. In that case, monotonously increasing stack will be great. So the idea behind this is that given an array, you want to find the next greater element. So when you want to push the element into the already existing stack, you find the last element and see if it's um, smaller. See if it's bigger than the one that you want to push into. And if it's bigger, then it means that it's not satisfying the requirement or criterion. So you pop it out from the top of the stack, and then you compare the next elements and so on and so forth. You repeat the same technique, and yeah, keep on comparing. So well, I found a question on LeetCode that perfectly uh, would summarize the use of this algorithm. So let me share it with you first. Yeah. So today's question is daily temperature is 739. It's a medium difficulty, and although it has only a few lines, it was really pretty difficult to grasp at first. But what the question is asking you basically is to find um, the difference in days in between the maximum temperature in the array and the current temperature. So what it means is that, let's say, for example, um, you have temperature 73. What is the next maximum temperature? Next bigger temperature? It's 74, right? So the distance between 73 and 74 is 1. So that's why you put 1 as a resulting, the first element of the resulting array, or a stack if I would choose to use stack later. Um, for example, 75, you don't compare it with the elements behind, you only compare it with the no, you can also compare it with the elements before it, but you just have to find the element that has the next element that has the higher value than this. So that will be 76. So so that will be a distance of 1, 2, 3, 4. So 4, right? So that's why they put 4 as the second indices. So now that we understand how um, what kind of output we're expecting from a given input, um, obviously there would be a brute force approach where um, you've iterated through an array, and given an array, you traverse through the array again and then see which one has the next higher temperature, and then return the indices. But if we do that, then that would easily have a time complexity of O(n) square with the repeated iterating loops. So, so like I explained in the beginning, we could use monotonous stack technique. Uh, and how are we going to use this? Let me visualize it with the paint. So, um, I'll also connect my mouse really quickly. So, given an array of 73, 74, 75, 71, 69. Okay, let's just uh, put the initial array like this. We'll just shorten it for the sake of the example. So we initialize the stack first, right? Because obviously we have to maintain the monotonously decreasing array, the sorted ones, and then just pop out the temperature that is uh, lower than the one that we want to push into. So that would be so let's say we initialize a stack like this. We put the initial elements, and what's important is because we have to return the indices for the stack, we'll just start with the indices of the first element, which is 0. And then if you see the second element, it's already bigger than the first element, so we also put it in the stack. And then the next element is also bigger um, than the first and second elements, so we also put that. Now, we see that uh, the number 71 is smaller than 75. So this element is the fourth element, no, 0, 1, 2, 3, third element. And since we cannot put uh, hmm, I don't know why I was doing this way because it has to be decreasing, but I was increasing. So I'm sorry about that. I'll just quickly write it again. So let's say 75, 73, 70, and then 74. Just like this. We put the first element 0, 0 indices. Second element is smaller than the first element, so we put 1. Third element, second element, third element, but the second indices is also smaller, so we put it like this. But as you can see from the fourth element, the third indices, it's bigger than the last element that was put into the stack. So we have to move this outside. So we have 2 here. And then when we have the resulting array, so distance between 2 and this is the third element, so that's this is 3. So 3 minus 2 is 1. So that's where the second 0, 1, 2 second indices um, second index of the array is the value of the second array, which is 1, right? Because um, the distance between this temperature and the next higher temperature, 74, is just 1. So this is correct. Now we compare 74 with the next element that hasn't popped out yet, which is 73, and that is 1. So we do the same thing again, 3 minus 1 equals 2. So for the first indices, which is this position, we have to put 2 there. So that is 2. When we check the distance between 73 and 74, as you can see, 1, 2. So we put 2 there. And now when we get to the first element, 75, we can already see that 74 is smaller than 75. So it is correct. So that would be 0. And then here, um, when it compared to the first element, uh, 0 minus 4 is minus 4. So for the fourth, so the third indices, absolute of minus 4 is 4. So we put 4 here. So this is like the basic logic behind solving this question. So yeah, now let's try to code it and then see if it works. So basically we would have to start with um, initializing a stack. So that would be stack equals, and then we also have to initialize an array. Um, so list of zeros for the answer with the same length as the input list. So that would be uh, answer equals 0 times the length of the temperatures. Now, we have to enumerate over a list of temperatures, right? So um, that will be for I in range length of temperatures. For I in range length of temperatures. So what was the condition again? While there is a stack is not empty, and um, we're moving from the back, right? We're checking for the back, so that would be temperature, um, temperature stack. We're looping through the stack as long as it's not empty and the current temperature is greater than the temperature at the index of the last element in the stack. That would be -1, and this has to be lesser than the temperature of the current index. Now, excuse me, but J, now we are going to do the calculation here of the finding the distance between the current indices and the maximum temperature indices. So we first pop the last element if it's smaller, right? So that would be stack dot pop, and then the answer of J is equal to I minus 1. So that's the number of days between the previous and current temperature. And now what we do is uh, uh, we update the answer list. Yeah. So we calculate the distance and then we update the empty answer list, or not empty, depending on how far the loop has proceeded. And now we have to apply the current index to the stack. So that will be stack. Oh no, it has to be stack. It has to be inside the while loop. No, it has to be inside the for loop. So stack dot append yeah, yeah, yeah. Uh, yeah. So now we return the answer array, and hopefully this is correct. Oh, what is wrong? Temperatures. Oh shit. We have a wrong answer. We can see that the indices are, no, this is 4 or 5. Let's go over again. Stack is empty stack, 0 times length temperatures for I in range length temperatures, while stack is not empty and the temperatures stack -1 is lesser than temperatures -1, then J is stack pop, and answer J is I -1. Is it I minus? No, it's not I -1. It's I minus J, because we have to calculate the distance between the um, popped current indices and the higher temperature. So that will be indeed correct, I hope. Yeah, yeah. As you can see, it got all the test cases accepted. Yeah, so that was it for today, guys. Uh, Monotonous stack, and let's see the time complexity. We beat 64%, and I believe that should be oops, okay. I think it should be ON, because we're only comparing each element of the stack um, to the ones that it's higher or lower than its value. So yeah, that was it for today, guys. Thank you guys for watching. Uh, I think this was the last bit of stack and cues, the monotonous property. Um, I think we're gonna move on to heaps, but if there is more example that I find interesting tomorrow, maybe I'll do that beforehand. But yeah, see you guys, and thank you for watching.